Okay, so the first thing is we have an equation going on, and I'm going to graph it, and we're going to do all those things that we normally do. Okay, but my question for you is, this equation, I can't actually enter it in my calculator. So there's a problem with this equation right now with entering it. Who can identify that problem with it? Plus 12 at the back. So y equals needs to be alone. Got it? Does that make sense? To go into your calculator, you have to have y equals alone. So then we're going to revamp it and put it as a plus 12 across the other side. Okay? Now we can go. Type away into y equals. Make sure it's a baby -2. Okay, so here's my screen. I did it off of a Zoom 6, which is the 10 by 10, right? Okay, let's make a window here. My x-min, I think this -10 is good. I really don't need 10. Do you want to just do like 5 on that side? Is that okay? So -10 over here is good, but maybe just 5 on that side. So -10 to 5. Okay, I'm going to go -10 to 5 across this way. Good. The -10 down here is fine, but I need higher on the 10 up there, right? So -10 to, should we just like 15? So I'm going to go to my window. I'm going to change some stuff. Okay, now vertex. So we're going to use our calculator to get that vertex. You're going to be looking for a max, and then we're doing the left-right system. Okay, can you get me a coordinate up there? Second, calculate max, left and right. -312 was my finding. Direction of opening, it opens down. Okay, it got flipped, so it's opening downward. The domain is forever left and right. The range, you have to do it in a specific order because of its direction. So the low is down forever. And the highest is a specific height it reaches and stops at that height, which is 12 square bracket, exactly, precisely 12, like it hits 12. Axis of symmetry, remember when we cut it through the middle? And how do you make a vertical line? We have to write an equation of x equals. Please don't forget that. Which x value will I cut right through on my travel? -3 is the x value. Okay, Next is my y-intercept. So that's here on the visual. What do we know about this coordinate right now? There's something we do know for sure without the calculator. What's that? What do we know about this coordinate right now? 0 for the x. It's 0 something. Okay, so what do we do with our calculator then if we know that? We just trace, and you tell your mouse to move to 0. Just tell your mouse to move to 0. What's another way I could have found it? Using the table of values, right? You could activate a table, look for 0, comma. Okay, this time we're doing x-intercepts. So the coordinates are going to be like this now. Y is 0. So this is what's happening. And this is a calculator. Remember this one? You have to do the 0. And you have to do it as a left-right. Okay, and you have to do it 2 separate times. So this is the plan. 0 left, right, 0 left, right. Okay, so this might take you a minute or two, so I'll pause and go for that. I've given you. So what do I know on the grid? I know negative 312. It's a little bit off, but can you write it up there? Remember, that was our vertex. And then negative 0.5-ish right there. X-axis, right? Negative 5 and some. And then over here, negative 6. Do you see where they all hit? Those are the x-intercept numbers. This is the y-intercept number, the vertex number. All right, I'm going to connect as best I can. Okay, good. Sketching now. What's the coordinate when x equals negative 2? So negative 2, comma, I have half the coordinate already. How do I find the full coordinates if I know the x value? What's the process? If you know the x value, tell it to go there. As long as you have your mouse going, negative 2, enter. Boom, it goes there. You can just tell your mouse to move to any x value. Okay, so it makes sense to me where it is, negative 2, comma 10. Using my sketch here like that. What are the x values when y equals 4? Okay, this is the opposite process. We know the y value. We don't know the x. So here's the process. If we forget, you're going to go y equals 4. You're going to make a line at y equals 4. So you're going to go into your y2 equals window, or into your y here. 4. So where does this graph hit that height? Right here and right here. Okay? I want to know what are the x values. I just want to know what are the x values of when it hits there. So you're finding some kind of intersection. Okay? So when you look at your mouse, right now when I do my intersection, my mouse is going to this one because it's closer to that one than that one. So just before you do it, make sure you move your mouse. Intersection, enter, enter, enter. Okay, before I try the intersection, I'm going to trace and move my mouse. Okay, it will go to the intersection it's closest to. Okay, why did I not write -1, 4? Why didn't I write the coordinates? Because the question just said, what are the x values? I don't say, what are the points? I don't want that. Just what are the x values? Okay, and then the last question on this page says, what is the point that's symmetric to the y-intercept? So here's what I know. That intercept.
The last question, answer -1.
Both of them. Because where does it hit that height? Two different places. On its way up, and then back on its way down, it'll hit that height again. Right? Okay, so what do I know? Symmetric points always occur at the same height. They will occur across each other, so they're always on the same height as each other, right? So what do? Y2 equals same thing. Okay, can you get me that other point? And I'm going to write it as a point because it told me in the directions. Again, making sure your mouse is closer. Okay, -6 was the coordinate, the point where they were meeting up with each other. Okay. So again, where this parabola is hitting this line across. Is this a quadratic? We're going to answer yes or no and kind of justify why. Okay, this first one, would we call it a quadratic? No. Reason? That ends up making it cubed, a cubic. Is the second one a quadratic? The answer is yes. What's the reasoning? Timesing that will make a x squared. Okay, I have two x's getting multiplied. So in grade 10, you learned about foiling stuff, right? Foiling it out. Question 3, yes or no? Yes. I see an x squared. I don't see any more. Next one, what do you think? Yes or no? No? What's the reasoning? 3 x's getting multiplied will produce, if you multiply, it will produce a x cube. Because 3x is getting multiplied somewhere, right? And then the last one is a yes. Because the multiplication, when I FOIL it out, will produce an x squared. Okay, without having this in your graph, does it produce a min or does it produce a max? And how do you know? So what are we looking at to know? What's our look at number? Which number is important to look at? Who's the boss of this thing that makes it happen? X squared. And how many x squareds do we see? -3. So that's how I know. If I have -3 x squareds, we're flipping. So that if we flip, we have a max. Without graphing this one, what's the y-intercept and how do you know this? What is the definition of what a y-intercept is? When x is 0. Okay, so process that. What happens to this equation if x was 0? What kind of number does that come out to be? All this is 0. All this is 0. Subtract 4. Does that make sense? Knowing the definition, there's no x, so we come out to be -4. And the last of this says, where's the vertex and y? So whenever you're doing any parabola, do you understand the vertex is alone? These will be symmetric pairs, right? These will be symmetric pairs. There's a bunch of symmetric pairs, except for the poor vertex, right? It's all alone. It will never have a partner. So can you figure out on the chart which one the vertex would be? Well, that looks like it have a symmetric partner. Well, those are symmetric partners. These are symmetric partners. So which one is my vertex? Okay, does that make sense? Understanding what's going on the graph, right?